Alright, good morning, good afternoon. This is the 6 fundamental theorem of algebra. To apologize if there's any discrepancies here because, well, I'm having to do this in a different location and at a different time than I usually do. So, our goal here is we want to use the theorem to write a polynomial equation of at least degree with given roots and identify all the roots of a polynomial equation. You will use the calculator for a lot of this, so kind of go with that. So, the first thing I want you to take note of, there's some statements here on page 445. All they're basically telling you is like the different ways we can write the roots. Don't forget that the r is the root is the x-intercept. These are all the solutions and just different ways of saying the same thing. So, for example, we want to write a polynomial equation in the simplest form with the zeros of -3, 1/2, and 1. So that means the graph crossed at -3, 1/2, and 1. Well, the first one is easy. Just do the opposite of -3 and say x plus 3 in parentheses. The second one with the fraction, I don't like dealing with the fractions. The book actually deals with the fractions. The easiest thing for me to do is this. The denominator goes with the x, so you'll write 2x. And then the numerator will do the opposite, so -1. Okay, so again, the denominator goes in front of the x, the numerator is the number that's there that's kind of off by itself. And then the next parentheses will be x minus 1, the opposite of the x positive 1. Okay, then we can multiply. You can see here I'm going to multiply the x plus 3, and I'm going to do this with the vertical method. So you can see here how I multiplied, did the 6 minus 1, combine my like terms, and then I can multiply again by the x minus 1, and I'm trying to squeeze it here in the space that I've got, but you can see what I've done. If you have any questions about this, please feel free to ask me through Edmodo or just ask in class. So finally, when I combine like terms, I get x cubed plus 4x squared minus 8x plus 3. So that is the polynomial of least degree, but that's basically what we do. So let's look at another example. Again, I have 0, 2/3, and 3. Okay, with a 0, I'm just going to put an x. Okay, then again, the 2/3, the 3 will become the number in front of the x, and the minus 2 will become the number by itself, and then x minus 3. Okay, do distributive property, x times 3x is 3x squared, x times 2 is negative 2x. And then I'm going to multiply that times x minus 3. So you can watch me here. -3 times -2 is positive 6. -3 times 3 is negative 9. 2 times 1 is negative 2. And then 3 times 1 is 3. And there you go. That's that one. Notice here how that had an extra x. Each one of those has an x, and we factored out the x if you could look at the first step. Okay, so now on page 447, there is the complex conjugate root theorem, and that basically says if you have an answer that comes out as a plus bi or just bi, then you have its opposite, a minus bi. Always. So complex roots with the i's occur in pairs, one in positive, one in negative. Always. Okay, so we're going to write in simplest form. I'm doing another example. I kind of did it a little differently than what the book did. And we're going to have this with where we have these different types of roots. Now, keep in mind that the 1 plus i should have a root of 1 minus i. And then the square root of 2 should have a root also of negative square root of 2. So there's actually 5 roots here. We're looking at 1 plus i, 1 minus i. Square root of 2, negative square root of 2. And then we've got that one with negative 3. So when we write this out, you're going to see a very long parentheses, x minus, notice how I put that in extra parentheses, 1 plus I, x minus again, 1 minus I. Then I'll have x minus the square root of 2, x plus the square root of 2, and then x minus 3. Now, keep in mind that what you've got here is that you can you got to make sure that there's some special little shortcuts if you pay attention to the ones with conjugates. So the ones that have conjugates, there's actually some little shortcuts that will help you kind of multiply those. Pay attention to those as you see me multiply those out. So when I do I think I do the x minus the square root of 2 first, x plus the square root of 2. Okay, when I multiply those two, square root of 2 times square root of 2 is just 2, because 2 times 2 is 4, square root of 4 is 2. Positive square root of 2 times x is the positive square root of x. 2 square root of 2x. Okay, x times the negative square root of 2 gives me the negative square root of 2x. X times x gives me x squared, and notice how the middle terms cancel out, leaving me x squared minus 2. Again, that's something to take note of. Maybe try another couple of examples and you'll see how that works. So these two right here will become just that x squared minus 2. Then when I do the other one, the x plus or x minus parentheses 1 plus I times x minus parentheses 1 minus I, doing distributive property there, that's a little bit easier with that one. X times x is x squared. X times a negative 1 is negative 1x. X times an I is, we'll say, ix. Then negative 1 times x is negative 1x. Negative 1 times negative 1 is positive 1. Negative 1 times I is negative 1i. Then I'm going to do the i's. Negative ix. Negative I times negative 1 is positive 1i. And then negative I times positive I is negative I squared. And remember, I squared is a negative 1. So, combining my like terms, I have x squared. The ix's cancel each other out. The 1i's cancel each other out. So notice here, the i's are disappearing. Negative 1x minus 1x will give me 2x. And then the negative I squared was positive 1, actually. 1 plus 1 is 2. So, there is a shortcut to that you can kind of develop. Kind of pay attention and maybe put that into a note card. That will help you. Make that a little bit quicker. Okay, so now we're left with x squared minus 2x plus 2 times x squared minus 2 times x plus 3. Go ahead and multiply that out. So again, I like to do the vertical method. I would do vertical method here. If you want to do distributive property, you can. You can see how it's playing out and how I'm doing the multiplication. Notice how I started the x squared on the second row under the x squared. That way I'm keeping them lined up. And then I got the 2x cubed and then x to the fourth. Multiply, combine your like terms. Notice the x squareds cancel out. And then I can multiply by the x plus 3. This one I'm going to do by distributive property, probably just because it's just easier for me right now. But again, notice how I'm making sure I write everything out, and then as I combine my like terms, I'm making sure to cover every term as I write my final answer. So that way I don't make any mistakes. Okay, so we're right now we're writing that out, combining my like terms. The x to the fourth combined to give me x to the fourth. X cubes combined, there was only one x cubed, only one x squared, 2x's, 12 minus 4 is positive 8, and then the minus 12. And there, you're done. Yes, I'm sure you are going to say it's a lot of work, but that's okay. Some problems are going to have some work. Alright, so now we're to the fundamental theorem of algebra. The fundamental theorem of algebra allows us to, say, determine the number of roots. Basically, it's just saying what I've been saying before. The degree of the exponent of the polynomial should be the number of solutions you have in for the equation when you set it equal to 0. Okay, that's basically all it says. So what we're going to do is we're going to find the roots of x to the fourth plus x cubed plus 2x squared plus 4x minus 8. Set it equal to 0. Okay, again, we go back to our p's and q's where we can do that synthetic division. So we got 8. 1, 2, 4, and 8. Those are the numbers to go into 8. Q is just 1. So P divided by Q is just the same as P. Positive and negative, 1, 2, 4, and 8. Now again, just to make sure it makes it easier for yourself, go ahead and graph this. When you graph this, you will get that graph. And you can see here there's two spots where it looks like it's crossing. One's at -2, the other one is at 1. So if you take those, try those with synthetic division, we can do that with synthetic division to confirm that it works. And you can see here, as I do my synthetic division, bring down the 1, multiply by -2, combine, multiply by -2, we get a 0 at the end, so that means that does work. Okay, and continuing from there, I'm going to do the 1. Bring down the 1, multiply by 1, combine your like terms, that type of thing. And what happens here is, again, this started out with x to the 4th, the next one became x cubed, now I have an x squared, and -2 and 1 did work. So now I'm looking at x squared plus 4, and I can set that equal to 0. Move the 4 to the other side, subtracting, and I have x squared is equal to -4, take the square root, and I get the square root of 4 is 2, and because it's a negative, I have the I. So plus and minus 2i. So my four answers are -2, +1, 2i, and -2i. Four answers, degree of 4. Okay, so here's another example, and we're going to do the same thing. Do the p's and the q's. And you can see, again, for 20, it's 1, 2, 4, 5, 10, and 20. Q is plus and minus 1. P divided by Q, basically the same thing. Do the graph, and you can see that it crosses, it looks like in two spots at -5 and +1. Not worrying about anything else like local mins or local maxes, we'll talk about those later. We're just worrying about right now, where does it cross the x-axis? And of course you could do a graph trace and check those zeros. But we're also doing this synthetic division so we can keep simplifying this further down and get it down to something we can work with to find the other answers. So doing the synthetic division, write down my coefficients, 1, 4, -1, 16, and -20. Then go through your synthetic division, get the 0, so -5 did check out. Then do the 1, same thing. And again, we're back to x squared plus 4. Just that's a weird coincidence that that was the same. Subtract, take the square root, and don't forget when you take the square root of a negative number, you have I. Plus and minus 2i. So we have -5, 1, 2i, and -2i. Okay, so that's that. You'll be working on an assignment on that on Thursday, so make sure you have that ready or on the next day. And so if you do have any questions, feel free to ask there and then. Thank you so much.